In this video, we are going to discuss order of operations in the context of processing complicated formulas and expressions. So business applications often demand the use of complicated formulas. When you look at these visually, they might look confusing and lead you down the wrong way in terms of order of operations. But we're going to take a look at them so you can recognize the visual cues that will help you process what you're looking at and calculate these expressions properly. So consider the calculation shown here, which is typical for a business statistics class when calculating something called a z-score or a test statistic. So this expression says 9 minus 3 over 12 over the square root of 16. In other words, 9 minus 3 divided by 12 divided by the square root of 16. Now, if you just sort of write that on a line, what you get is this. You might think it's the same as this expression here, 9 minus 3 divided by 12 divided by the square root of 16, which is what I just said, right, when reading the formula stacked as it is above. But the expression 9 minus 3 divided by 12 divided by the square root of 16 evaluates to 8.9375, and the answer to this expression is 2. So those are significantly different answers, and you have got to look at this expression and see it for what it is. All right, so that's what we're talking about here. So how can you tell that this comes out to 2? The answer is that long horizontal line. The long horizontal line that is separating the top from the bottom of the fraction is a formatting cue. It's telling you that the top of the fraction has to be calculated separately from the bottom. So let's do this example. Example 2.3 says, evaluate the expression 9 minus 3 over 12 divided by the square root of 16. All right. So taking a look at this horizontal line, you see how it visually splits the top from the bottom of the expression. You see how the division sign that is in the bottom of the expression, that's called the denominator of the fraction, is smaller. It's at an angle. The format of the expression is indicating that this 12 divided by this square root of 16 goes together. This 9 minus 3 goes together, and then the division happens. So let me write the expression again. Now, showing the formula this way is often considered to be enough to show what you're supposed to do here. That long horizontal line is separating the top from the bottom, so we have to separate the top from the bottom in the calculation as well. The way we do that, using the tools that we've already gone over, is to think of the top and the bottom as surrounded by parentheses. So if we enclose 9 minus 3 in parentheses, that is going to take place first. If we enclose 12 divided by the square root of 16 in parentheses, that is going to take place next. And then the division signified by the horizontal line will take place last, which is what we actually want to do. What we want to do is to make this thing go 6 divided by 12 divided by the square root of 16. Square root of 16 is 4. 12 divided by 4 is 3. And you get 2, right? But if you don't do the operation on the top, separate from the operations on the bottom, you're going to come out with 8.9375. So these parentheses are going to solve it for you. Once we enclose the top in parentheses and the bottom in parentheses, what this expression becomes on one line is open parentheses, 9 minus 3, close parentheses, divided by open parentheses, 12 divided by the square root of 16, close parentheses. And this we can solve using our usual order of operations. Order of operations says you have to solve what's inside parentheses first. All right, so if I take a look at this set of parentheses versus this set of parentheses, take the one on the left first. Inside the first set of parentheses, we have 9 minus 3, which comes to 6. I'm going to rewrite this division symbol. Now I'm going to deal with what's inside these parentheses. So actually, we have to separate out what's going on in here because we have to follow order of operations within the parentheses. Okay, so I'm going to start with the highest order of operations within the parentheses, which is the square root. square root of 16 is 4. 4 times 4 is 16, right? So filling in the rest of what we had in the original expression, above we have open parentheses 12 divided by 4, close parentheses. What do we do next? Well, we have to continue inside of our parentheses because the parentheses, of course, is highest in operational priority. So 12 divided by 4 is 3. So now we're left with 6 divided by 3, and 6 divided by 3 equals 2. So once again, looking at the original expression, we might think it translates to this, which would get us the wrong answer. What you have to pay attention to is the visual cue. That horizontal line between the top and the bottom is visually separating this fraction into the top and the bottom, the numerator and the denominator, and that they have to be calculated separately. And then the division takes place in order to get the correct answer of 2.